Welcome back to month 3. In the last lessons we set the Zero Trust foundation. Now we get hands-on with the platform that gives us the telemetry behind it. This lesson is Microsoft Defender for Endpoint and Advanced Hunting. By the end you'll understand every layer of the platform, and you'll be writing KQL queries against raw endpoint data to hunt threats yourself. First, let's dispel a myth. Microsoft Defender for Endpoint is not just an antivirus. It's a layered platform. You get next-generation antivirus that's cloud-backed and behavior-based. You get EDR, endpoint detection and response, which records rich behavioral telemetry and raises alerts. You get attack surface reduction rules, network protection, and threat and vulnerability management. The layer that turns it into a hunting platform is EDR, because every onboarded device streams its behavior into the cloud for you to query. Let's single out attack surface reduction, because it's one of the highest value controls you can deploy. AS are rules block known risky behaviors proactively. Classic examples: stop Microsoft Office applications from spawning child processes, block credential theft from the LSASS process, block obfuscated scripts. The smart way to roll these out is in audit mode first. Watch what they would have blocked using advanced hunting, and only then flip them to block so you don't break a legitimate workflow. Telemetry only exists once a device is onboarded. There are several ways to do it. Intune is the modern default for managed Windows, but you can also use group policy, a local onboarding script, or configuration manager. macOS and Linux have their own native onboarding paths. Whatever the method, onboarding installs the sensor and connects the device to your tenant. From that moment, its process, network, file, and logon events start flowing into the advanced hunting schema. Advanced hunting is a query tool over up to 30 days of raw event data, and you write those queries in KQL, the Custo query language. The data is organized into tables, and the endpoint ones all start with the word device. DeviceProcessEvents, DeviceNetworkEvents, DeviceFileEvents, DeviceLogonEvents, and more for registry and loaded images. The important thing: every single row carries a device ID, a timestamp, and a set of initiating process fields describing the parent. Those are the columns you'll join on. KQL reads top to bottom, piping a table through each operator. Learn 5 verbs and you can hunt. Where filters rows. Project chooses which columns to keep. Summarize aggregates, like counting. Parse pulls a value out of a text field. And join correlates 2 tables. Here's a real hunt: start from DeviceProcessEvents, filter to the last 7 days, find cases where Word or Excel launched PowerShell or command prompt, then project just the fields that matter. That's a classic suspicious office child process query. Now the powerful move, correlation. A let statement names a reusable subquery, here, suspicious PowerShell with encoded commands or download cradles. Then we join that to DeviceNetworkEvents. We match on the device ID and on the process identity, because the network table records the initiating process that opened each connection. Finally, we summarize how many connections each command line made, to which URLs and IPs. In one query, we've tied a suspicious process to its command and control traffic. Once a query reliably finds bad behavior, don't keep running it by hand. Use create detection rule. That schedules your KQL to run on a recurring frequency, raises an alert whenever rows come back, and can optionally trigger automated responses like isolating the device or collecting an investigation package. And every alert it raises is mapped to MITRE ATT and CK tactics and techniques, so the behavior gets a shared, standard name and slots into the kill chain. That's how a hunt becomes durable detection engineering. For hands-on investigation, you have 2 great tools. The device timeline gives you a chronological stream of everything that happened on a machine, perfect for reconstructing an incident. And live response gives you a secure remote shell straight into the endpoint. From there you can collect a suspicious file as evidence, list running processes, quarantine a file by its hash, or run a triage script from your library. And when you need to contain, you can isolate the device from the network with a single action. Let's recap. Defender for Endpoint is a layered platform, next-gen antivirus, EDR, attack surface reduction, network protection, and vulnerability management. Its EDR telemetry lands in the advanced hunting schema, which you query with KQL over the device tables, joining process, network, and logon events to correlate behavior. Your task: in a test tenant, write a hunting query for likely lateral movement. Find remote interactive RDP logons where the same remote IP had more than 5 failed logons before a success within an hour, summarize and project cleanly, then join back to DeviceProcessEvents to show what that session ran. Describe how you'd promote it to a custom detection role and which ATT and CK technique it maps to. See you in the next lesson.